Huh? Which theory we were talking about? Theory of relativity, right? Huh? Traffic flow theory. Okay, what does it give you? What does this theory include? Relations between
speed, flow, volume.
okay, relation between speed, flow and density basically. Okay, I showed you some graphs, okay, and there were some equations, okay, and all of them are part of traffic flow theory. And then we went on to the beginning of the theory, which was given by Bruce Greenshield. Okay, he's a friend of mine. We were born together in 1930s. Okay, so we started with this curve or this line, speed density. Okay. And we know this the equation of a straight line, so we have the equation for speed density. And using this, and there was another equation which you can see on the top, right? V equals to S into D. So using that and this one, we came up with the equations between flow and density and flow and speed. Okay. Yesterday I wrote them as 65 upon 110 and 110 upon 65. If you divide it, you will get these numbers: 0.59, 1.69. Okay. Now, if I go back, these equations which you see, they are for curves, right? Okay, and the curve is here. Where am I going? These are the curves, right? The first one between flow and density, the second one between flow and speed. When you reach maximum flow, what do we call it? Capacity. Okay, so we want to know the capacity of the road. This is important for us. Okay, so when you reach capacity, what happens with the slope of the curve? Any graph? Change. It changes. Very good. Everything changes in this way. Okay. But what happens? It changes to what? You guys should go in politics. The answers are correct but useless. Yes. It becomes 0. Yeah, it changes to 0. It decreases to 0. Okay. Now, if I give you the equation of the curve, can you give me the equation of the slope of the curve? Doing what?
The equation y
Like I said, you should go in politics. What do we do with the equation of the curve to get the equation for slope? We take the derivative. Okay, so we already have the equation of these curves, these two. Okay, so these are the equations of the curve. V equals to 65d and so on, so on. V equals to 110s, so on, so on. Okay, so these are the equations of the curve. You take the derivative, it will become the equation of the slope. Okay, and when you are at capacity, the slope is, what did he say? Slope is 0. Okay, so I take the derivative and put it equal to what? 0. I can do the same thing with both equations, right? Because in both cases, it's 0. Whether that curve or that curve, it is 0. Okay. This is what is done here, no? Okay. So this is right done here, right? So this should not be here. Okay. So derivative of the first equation. Okay, the first equation is between flow and density, right? So dV upon dd equals to what? 65 minus 2 into 0.5909 D, right? And this should be equal to what? 0. So give me D. Huh? 55 vehicles per mile per lane. Okay, clear up till now? Now, this is the D when slope is 0, right? And slope is 0 at maximum flow. And maximum flow is called as what? Capacity. So this is the D value when you reach capacity. This is the density, value of density when you reach capacity. And we gave it another name. What was the name? Critical density. Okay, so this is my critical density. I will write CR here. Per lane. Capacity is per lane. This is for that equation. Remember, we had a curve, right? We had some data. You change the data, these values will change. Okay, any problem till here? Now, if I do the same thing with the flow speed equation, so dV by ds, it will be what? 110 minus 2 into 1.6923 S, and this should be equal to what? 0. So S equals to what? Huh? Give me in decimals. Yeah. So again, this is the speed when slope is 0. Slope is 0 when flow is maximum. Maximum flow is called as capacity. And the speed at maximum flow and this, or the speed at capacity, is called as what? Critical speed. So I will call it critical speed. Okay. So now you know what is the density at capacity. Now you know what is the speed at capacity. Okay. Now between these parameters, I have equations, right? So for example, I can put critical density in the first equation between V and D, and I will get the capacity. That V will be my capacity, right? This is density at capacity. If you put this value, the value you will get for flow rate will be my capacity. You will put D here. That's it. And the flow rate is the maximum flow rate, right? Because this is the D at maximum, right? You can do the same thing with the speed. Because this is the speed at maximum flow rate. So you put the speed here, you will get maximum flow rate. Okay? And I have the third equation as well. Which one is that? We used it yesterday. Flow rate equals that one, right? Flow rate equals to S into D. You can use any of these equations, right? Clear or not? Huh? So give me the capacity for this highway. Use any equation, whatever you like. You should be getting the same answer. One 787. Any problem? Clear? Okay. Now look at the speed. The speed is 50. Look at density. Critical density is how much? 55, right? 55. Look at this graph. What is the maximum density? 110. Maximum is 110. Critical is 55. How much is this? Half. So jam density is double of critical, right? Jam density is double of critical. Maximum density, jam density is double of critical. Okay, so now we have one more relationship, that D jam equals D critical multiplied by 2. Okay, now look at the speed. Critical speed 32.5, right? How much is maximum speed? 65. Okay, we also call it the free flow speed. So again, what's the relationship? 65 and 32.5. Same, double. Okay, so critical is half of free flow, or free flow is double of critical. Free flow speed is double of critical. Clear? Now you can see the capacity is 1787 vehicles per hour per lane. Okay, capacity is always per lane, is always shown as per lane. Capacity. Okay, it's a default, it's a notation. Okay, so we don't show the capacity of the whole road, we show the capacity for a road but per lane. Okay, do you think that every road will have the same capacity? No, because this capacity comes from the data which we collected on this road. You collect data from some other road, you get some other road. For your term projects, you will do this. Okay, and you will get different values, I believe. Okay, clear? Don't come to me, his capacity is 1500, why mine is 2000. It can happen. Okay, just to prove the point, we have another example. So in this example, they already gave me the straight line equation between speed and density, right? The straight line is between speed and density, right? The others are not a straight line, they are something else. Okay, now they are saying find out the free flow speed, jam density, derive the other relationships between flow and speed and flow and density, and find out the capacity. Clear? Three things. Let's start with the first one. Free flow speed. I'll go to the speed density curve. Don't look at the values, but look at the line itself. Look at the line. When I reach free flow speed, my density is what? 0. You have the equation, right? Between speed and density equation is given. So now you do what in this equation? Put 0 density. You will get free flow speed. Okay. What about jam density? You were saying something? No? For jam density, speed is 0. It's jam, right? So no speed. So now we'll do it what? I put speed as 0. I will get jam density. Okay. So give me that. Give me free flow speed and jam density. Very smart. Yeah, it's correct. I don't mind if you do like this, no problem. No problem. Yeah, free flow speed is 71.2. But I'm telling you how do you get it. Okay, so at free flow speed, density is 0, put density as 0, you will get 71.2, no problem. And jam density, you put speed as 0, density equals to what? 122. Okay, you get the point, right? How do I get it? Okay, if you take 1 minute extra, no problem. Okay, up till clear up till now. We did the first part. This was the first part. Okay, second part is find out other relationships. For other relationships, I have this equation. And which other equation we used? Flow rate equals okay, so from here I will take which one first, D or S? S, it's easier. V on D. Okay, so in the top equation you will put now V upon D equals 71.2 minus, I am opening the bracket now, 71.2 upon 122 D. So V equals to what? V equals to what? 71.2 D minus, how much is this? 0.584 D square. Let me put like this. Any problem? V equals S into D. So S equals V upon D. So I replace S with V upon D. Okay, so this becomes this. I open the bracket. I replace S with V upon D and then I open this bracket.
And you put D.
Then I put D over here. Clear? Any question? Yeah. They need these equations now. Okay. Now I'll go back to the same equation. V equals to S into D. And I will take the value of D from here. So D equals V upon S. Again, going to the first equation again, the top one. So S equals, I'm opening the bracket, okay, so V equals to what? Tell me. V equals to what? Uh, 71.2 S. 71.2 S. Sure. 122 S.
Minus 1.71 S.
Minus what?
1.7.
Okay. You have to display with this equation. Put V on one side, everything else on the other side. I believe you can do this. Okay, people who are taking pictures, do this. Okay, I'm doing more than taking picture. I'm recording the whole lecture. You guys are taking pictures. Old technology. But you still have to do it. Any question? There. Okay. This is the second part. Second part was give the equations between flow and density, flow and speed. We did it. Okay. The third part is calculate capacity. What did we do to calculate capacity? We take the derivative. Now they asked me for capacity. Okay. Last time, in the previous example, we were looking at what will happen to critical speed and critical density. So I took the derivative of both equations. Here you don't have to do this. You can pick one equation. Pick any one. Which one? This one or this one? We will do the voting. Okay. Who says this one? And who says this one? And the rest are sleeping. Right? There's no big deal. It will be the same, right? Okay, let us pick this one. Okay. So dV by dt is what? $71.2 2 into okay, and this gives you d critical of what? How much? 60.96. Okay, so this is the D when you reach capacity. Now you put this D back into this equation. The flow you will get is capacity. Okay, how much is this? Two one 70. So in the last question it was 1700 something. In this question it is 2100 something. You can see the difference, right? So it's not a small difference. It's a big difference. Clear? It can be even less than this or more than this. Okay, it can go up to 22,300 as well, 2,400 as well. Okay. It can be as low as 1,500 or 1,400. Okay. For practice, you can repeat the same procedure with this equation. Take the derivative, find out S and put it back in this equation. Okay. Or once you find out S, you already have D critical, you will find out S critical and you can put it in this equation. All three of them should give you the same answer. Okay, whether you calculate from S critical or D critical, all of them should give you the same answer. Any questions? Clear? Okay. We said there are two types of facilities, right? Interrupted and uninterrupted. What's the main difference between them? What's the difference between interrupted flow and uninterrupted flow? External interruption, right? And we put external interruption because of what? Because of intersections. Okay. So all these calculations we did up till now, the graphs, the equations, all of them were for uninterrupted. Okay. So traffic increases, speed reduces, density increases, and so on. Okay. So everything works fine when uninterrupted. When you come to interrupted, Okay, so the main thing is there is some external interruption, maybe a signal, a stop sign, a roundabout, and that external interruption will do what? It will stop you. Whether the traffic in your direction is high or low doesn't matter. Whether the density is high or low doesn't matter. You reach that interruption, you have to slow down. You have to stop. Okay? So obviously in those equations, the equations which we just did, was there anything indicating now there will be a signal? That there will be a roundabout, there will be a stop sign, there will be a car coming from the parking? So those equations will not work. Okay? So, but even on interrupted flow facilities, we may use those equations in some parts. Which parts? The parts when you have crossed the interruption. Okay? So you were on a signal. People who are coming on the signal, those equations will not work for them because the signal is stopping them. But what will happen when they pass the signal? When they cross the signal, until the next signal comes, their flow is uninterrupted. Next signal or next intersection, whatever. Okay? So in that part, when they have crossed one interruption and they are still far from the other interruption, they are uninterrupted. So in that part, you can use those equations. Okay? And obviously in that part, there is a group of vehicles, right, which are moving together. So you are applying those equations to that group, okay, which has passed the previous interruption and which is still not did not reach the next interruption. So you are applying on that group, in that part, on that group of vehicles. So the group of vehicles is known as platoon. So they are on the segment together, right? So that means what? They cross the interruption together. Now they are together on the segment. Okay? So we call them as platoon. Okay? So platoon is a group of vehicles which is on the uninterrupted part of the road. They are going together. So these equations apply to a platoon. Okay? But what is a platoon? The group of vehicles which are on the uninterrupted part of the road and they are together. They are moving together. Got it? Clear? Okay. There are some important terms for us, and they are, all of them are related to volume, and I have mentioned them earlier. Okay, one of them is traffic demand, then we have traffic volume, and then we have capacity. Demand, volume, capacity. Okay. Now, traffic volume means what? Traffic volume means what? Number of vehicles per hour or per day. Okay, but normally we take 1 hour. Okay. Hourly volume is more common. Okay, and here we are talking about hourly volume because we are comparing it with the other terms, capacity and demand. Okay, what is capacity? Maximum rate of flow. Maximum rate of. Okay, what is demand? What is demand? Demand is volume. Demand can be volume. Demand can be volume, yes. Or demand can be
Desire to pass. Desire to pass.
Desire to pass. What does it mean? Everybody desire to pass, right?
Pass a point.
Okay. But some of you will not pass, obviously. This is my job, right? Yeah.
So I have to pass a point in sequence.
Very good. Who is desiring to pass?
Okay.
The vehicles. Okay. How the vehicles desire to pass?
Number of vehicles.
Number of vehicles. So vehicles themselves desire to pass. You wake up in the morning, your vehicle is saying, take me out. I'm getting bored. Okay. Demand is number of people basically. Okay, and number of people obviously they are on the vehicles. Okay, jokes apart. But demand is the number of vehicles which are supposed to be on the highway. Demand is number of vehicles which are supposed to be on the highway according to the activity of the people. Okay, so 2000 people want to move from this side to this side. So 2000 is the demand. Got it? Okay. 2000 is the desire of the people. 2000 people desire to pass from this to this. So 2000 is the demand. Okay. Which of them is a constant number for a highway? For any highway, that will be constant. Which of that? Which is capacity is constant. The capacity of the highway cannot change from 1 hour to the other hour. Okay, the other two can change. Demand and volume can change. Which one affects the other? Demand affects volume. Demand affects volume. High demand, high volume, and vice versa. Okay. There can be certain cases in which demand can go more than volume. Demand can be more than more than volume, more than capacity. There can be cases where demand is more than capacity. Okay, we see it very often on the roads. Okay. You get stuck in traffic jam, long queues. So this is a situation when demand is more than capacity. Okay. If this happens, what can we do? There are certain actions written here. Or what can you do as a driver? Or what can you do as an authority? Let's say you are in the traffic authority. Okay, so you are planning, so you want to reduce a traffic jam. Okay, so you know on this road at this time there is a traffic jam. What can you do? Or you are the driver. Okay, so you know on this time and this road there will be a traffic jam. Okay, so what do we do?
Change it.
You tell your teacher, I cannot come at this time. Transfer me to the other section.
No, you change
And then you sleep at home till 12 o'clock. Yeah, you change to other highways. Okay, you change to other routes. You tell the driver there is a congestion ahead. Or the driver himself knows there is congestion on this road and he goes to some other route. In some cases, you may go to a longer route to avoid congestion. Because if you go there, you will be stuck in traffic jam for half an hour. This longer route will only take 5 minutes extra. Okay, so you take that route. Okay, so you can do this. Travel to another time. I already gave the example. I don't want to take section at 9 o'clock. We'll come at 2 o'clock, right? Where's the third guy? Okay, so you go at some other time. Okay, don't try this at when you get a job. Okay, you will be kicked out. But if possible, go at some other time. Okay, diverting travel to a different destination. You don't want Isata, right? Everything happens to us. Okay, but this could be possible if you are going for shopping, for example, or picnic, or something like this. Okay, where you can change your destination, that the place where you want to go. Okay, so I can buy from here and here. Okay, if I go here, there will be congestion, but there is an offer here. I have to go, right? Even if I lose my life, I have to go there. Okay, things like this. Or staying home. Okay, happy place. So you work from home. Okay, so all these things can be done to reduce congestion. Okay, so and you can do it as a driver, or the government can intervene and they can provide you these options. Okay, it's in the plan, by the way. When they calculate the demand of the highways and when they are planning for the road projects, they look at these things. The demand keeps on growing and growing. That means we keep on making this road bigger and bigger. No. So the person can go from A to B from this road. Okay, can I provide a different road for them, so half of them will go from there. Okay, it happens. Okay, they introduce new housing projects in different areas and so on. So demand can be balanced. Okay, shopping malls and hospitals, banks. Okay, staying home doesn't mean you stay home. Okay, like you can do your job without going on the road. You can do things online. Okay, now nobody goes to bank for, most of the 99% of the banking operations are online. You don't go there. Okay, even you can open an account now online. Okay, so staying home means that you avoid the road completely. You don't go to any other route or place or time. Okay, so this basically means nowadays doing it online. Okay, nobody stops working. Okay, so if we want to calculate the true demand of the road, the true demand of the road is the one which you see on the road itself right now, plus people who did this. Okay, so if there was no congestion, somebody who is going from another highway, he will be here. If there was no congestion, somebody who is going after half an hour, maybe he will go now. Okay, somebody who is who is going to a different place, maybe he will go to this place now. Okay, so he is part of the demand. Okay, so you have to take these things into account, and you have to keep in mind that the demand cannot be or will not be always the number of vehicles which you see on the road. Okay, now when the demand goes over capacity, there are few things which we want to calculate, few important parameters. For example, how much will be the delay, how many people will be delayed, and how long will be the queue. There are three important things for us. So we'll do one example. It's just an example to show you how they are done, how they can be calculated. But again, you can see some graphs here. So whenever I show you the graph is plotted from data, right? So if I change the data, the graph changes. Okay, so the calculations will change. Okay, now you look at this graph. On the x-axis you see time, on the y-axis there is flow. Okay, the flow is given in vehicles per minute. Vehicles per minute. The straight line which you see at 75, this is the capacity of the road. That's why it's a straight line, because we said what? Capacity is constant. So this road has a capacity of 75 vehicles per minute. Okay, and the other line you see is the demand. Okay, and demand changes, right? So in the first 30 minutes, the demand is 50. Less than capacity, no problem. 50 come, 50 go. In the next 60 minutes, okay, so from time 30 to time 90, the demand is 120. More than capacity, right? Okay, so what will start now? Congestion, delay, queue. Okay, so all this will start from here, from time 30. Okay, then you reach time 90 and the demand goes down to 65 now. Demand goes down to 65. Okay, this is less than capacity. That means what? All our problems are solved? Why not?
Yes.
Yes?
Because now
The queue is still there. At this time, we had a queue, right? The queue will take time to go, right? There is a traffic jam. The traffic jam will continue until the demand goes down. But it doesn't mean when the demand goes down, it will vanish. These are physical cars on the road, right? It's not a file in your computer that you do control or delete. Okay, it will take time to go. There's a long queue now. Okay, so this long queue will start to move now because the demand is now less than capacity. Up till this time, the queue was increasing. From here, queue started. Up till here, it was increasing because all these extra cars are getting in the queue. From this time, the queue will start to move. Okay, but it will take some time before the entire queue is gone. Got it?
So why they don't show
Where?
and they show only 60 minutes for the queue, which means like
Now they are not showing the Q. They are not showing the Q. They are just showing rate of demand and rate of capacity. That's it.
When it's higher than the capacity, and it's
There's the Q, but they are not showing it. A graph cannot show everything, right? You will have another graph to show the Q. Okay. This graph is not showing the Q.
I mean the capacity is.
This is the capacity,
Yeah. So it's higher.
and
than-
this is the demand.
Yeah.
The demand goes less. Demand goes less. Volume does not. This is not showing volume. If I can show you the volume, then it will show.
So
Okay,
you're
but it will
talking
show
about-
in the next slide. It will show. Okay. This is only showing the demand and capacity. This graph is only showing the demand and capacity. Demand is low, then high, then low. That's it. Capacity is constant. The other things I am saying is my imagination, right? Okay. So first of all, I want to know how long is the queue. Like how many vehicles are in the queue. Okay. From this time the queue starts, right? This is the capacity 75, and the demand is 120. So from this 120, 75 will go. The remaining is how much? How much is remaining? Huh? 55 or 45? 45. Okay. So every minute, this is continuing, right? So every minute, how many vehicles in the queue? 45. Okay. And how many minutes? 60 minutes. So how long is the queue? 45 vehicles into 1 hour? 60. It's per hour, per minute, right? 45 per minute. And for how many minutes? 60 minutes. Okay. You don't take it into 1 hour. Then that should be 1 hour as well. How many per hour? Okay. So 45 per minute added to the queue. And for how many minutes? 60 minutes. Okay. So total queue is 45 per minute into 60 minutes. And this comes out to be,
per hour.
3,000.
well, is it somewhere? This
Yeah.
2,700. 45 into 60 is 2,700. Got it? You understand 45 into 60, right? If you do 45 into 60, you will get 2,700.
Why did
Huh?
we just because they get 90 minus
Yeah, they calculated
I know.
how much is the capacity in 60 minutes, then how much is the demand, total demand in 60 minutes, and then they subtract it. That's what. But you can do it directly, no problem. Okay, clear? Now after this time, what is happening? Demand is less, 65, right? Capacity is 75. But we said there is a Q. Okay, so now when the demand is less, there is a chance for the vehicles in the queue to start moving. How many vehicles from the queue can move? The demand is 65, capacity is 75, so whatever is the difference will be taken from the queue. Okay, so difference is 10 per minute. Okay, total number of vehicles in the queue 2,700. How many are leaving per minute? 10. So in how many minutes these 2,700 will go? 270 minutes. 270 minutes, right? 270. Okay. Every minute 10 vehicles will go from the queue. So 2,700 vehicles will take 270 minutes. Okay. These 270 minutes are starting from where? From this point. Okay. So after 90 minutes, I need 270 minutes more to get the queue off. Okay. After 90 minutes or after this 270 minutes, there will be no queue. Got it? Any question up till now? Clear? So tomorrow we will continue with this example on how to calculate the delay. Okay. So if there are any questions, ask me now. You will come tomorrow empty mind. I'll not start from scratch.